Hey guys, here we are for lesson 7. We are going to be on page 55, comparing relationships with tables. So, 7.1, adjusting a recipe. Lemonade recipe calls for the juice of 5 lemons, 2 cups of water, and 2 tablespoons of honey. Invent 4 new versions of this lemonade recipe. So I'll give you a minute or two to do this. Go ahead and hit pause, come up with more or whatever they're looking for, and then go ahead and play and we'll go through it. All right, here we go. Hopefully it came up with some recipes. Number one that would make more lemonade that would taste the same as the original. So I need to make more, so I could just multiply each of the 3 ingredients by the same number. So I can multiply by 2, I can multiply by 3, 20, whatever you want. Just got to be multiplied by the same number. So if I multiplied by 2, I'd get 10, 4, and 4. So 10 lemons, 4 cups of water, and 4 tablespoons of honey. Number 2 says one that would make less lemonade but taste the same as the original. So then we're going to have to divide by the same number. So if I divided by 2, I would have 2.5 lemons, 1 cup of water, and 1 tablespoon of honey. Number 3, one that would have a stronger lemon taste. So then I just need to add more lemons. So I could have 15 lemons, 2 and 2, or 15, 4 and 4, or whatever. Just I have to have a lot more lemons than the other 2. And number 3, one that would have a weaker lemon taste. So I could keep the 2 and 2 and only put 1 lemon in there, and that'd have a weaker taste. Okay? So if we turn the page, 7.2, visiting the state park. Entrance to the state park costs $6 per vehicle plus $2 per person in the vehicle. How much it would cost for a car with 2 people, 4 people, or 10 people? So 2 people. We have $6 for the car. That goes every time. We're going to go $6. So, $6 for the car, plus 2, right? There's 2 people in the car, so 6 plus 2 is 2, or 8. 8 plus 2 more is 10. So it's going to cost $10, okay? Or we could have gone 6 plus 2 times 2, and 4 plus 6 is still 10. Okay, now we have 4 people, so $6 for the car, plus 4 times 2. Well, 4 times 2 is 8, so 6 plus 8 is 14. And then for 10 people, 6 plus 4 times, or just kidding, 6 plus 10 times 2. Well, 10 times 2 is 20. 20 plus 6 is 26. Okay, so there we have it. For each row of the table, if each person in the table splits the cost, how much will each person pay? So we just got to divide the second column divided by first column. So 10 divided by 2 is 5. So each person is going to pay $5 here. 14 divided by 4, if I pull out my calculator, 14 divided by 4, I get 3.5. We're talking money, so I need to add a 0. So each person is going to pay $3.50. And 10 people, 26 divided by 10 is 2.6. We need to add a 0, so $2.60. So if you notice, the more people you have, the less money each person is going to pay. How might you determine the entrance cost for 50 people? Well, so now we need 50 down here. So we still have 6 for the bus, and then 50 times 2. Well, 50 times 2 is 100. So then we're going to go 100 plus 6, and we get $106. Number 4, is the relationship between the number of people and the total entrance proportional to relationship? Well, if it would be proportional to the relationship, every time, no matter how many people come into the park, you would each pay the same price. If you notice right here, they don't pay the same price. Okay? Now, because they don't pay the same price, it is not proportional. Okay? It's this whole $6 per vehicle right up here. That's what throws it off. Okay? If it was just $2 per person, yeah, then it would just be 2, and so it would be proportional. But because the vehicle costs $6 as well, that's what throws it off. All right? 7.3, running laps. Han and Claire were running laps around the track. The coach recorded their times at the end of laps 2, 4, 6, and 8. Han's run, and then Claire's run. So we need to find the minutes per lap. So we need to find the constant proportionality, or second column, divided by first column. So 4 divided by 2 is 2. So 2. 9 divided by 4, after the fourth lap, she's up to 2.25 minutes per lap. 15 divided by 6, she's up to 2.5 minutes per lap. And 23 divided by 8, she's up to 2.875 minutes. So she's getting slower, right? But that makes sense. She's running more laps, getting more tired, and so she's slowing down. All right, let's look at Claire. Oh, no, that was Han. Han was slowing down, so he was getting more tired. So let's look at Claire. So 5 divided by 2, 2.5. 2.5. 10 divided by 4, 2.5. 15 divided by 6, 2.5. 20 divided by 8, 2.5. So Claire was running the same pace every time. She's running 2.5 minutes per every lap. Okay, so there's Han. 2.5, 2.25, 2.5, and 2.875. And here's Claire, 2.5, 2.5, 2.5, 2.5. Is Han running at a constant pace? No, because the minutes per lap is different. So Han is not running at a constant pace, so we'll put a frowny face. Is Claire running at a constant pace? Yes, because all the minutes per lap are the same. So Claire gets a smiley face. Write an equation for the relationship between the distance and time for anyone who is running at a constant rate. So remember, to write an equation, we take the constant proportionality. Let me get my pen here, quit moving the screen. I take my constant proportionality, 2.5. I put it with the first column, distance, and it equals the second column, time. So I can go 2.5 times my distance, we'll put d for distance, equals t for time. Okay, so there's my equation. Okay, and that's it. Pretty short today, pretty simple. So let's look at the summary. Here's the prices of some smoothies at two different smoothie shops. Smoothie shop A, we have the chart, and then smoothie shop B. If you notice, on smoothie shop A, they all have the same dollars per ounce, all 0.75 or 75 cents per ounce. Shop B, on the other hand, they don't. It actually gets cheaper per ounce the more you buy. So for smoothie shop A smoothie costs 75 cents per ounce no matter what size we buy. There could be a proportional relationship between the smoothie size and the price of the smoothie. We could write an equation. 0.75 times S, that's our first column, equals P, our second column, where S represents size in ounces and P represents price in dollars. The relationship cannot be proportional if there are different sizes on the menu that did not have the same price per ounce. For smoothie shop B, the cost per ounce is different for each size, hence it's not proportional, and we cannot write an equation. In general, two quantities in proportional relationships will always have the same quotient, or they'll always have the same constant proportionality. When we see some values for two related quantities in a table and we get the same quotient when we divide them, that means they might be in a proportional relationship. But if we can't see all the possible pairs, we can't completely be sure. However, if we know the relationship can be represented by equation, then it is proportional. Okay? So there you have it. So in your assignment today, you're going to have two questions on Canvas. The first one is like number 1 in your book on page 59. It says, decide whether each table could represent a proportional relationship. Write true if it's proportional and false if it isn't. Okay, so they give you two tables here. To find out, we just need to find the constant proportionality. So second column divided by first column. So we'd go 85 divided by 5, 79 divided by 10, 73 divided by 20, and 67 divided by 40. So all I'm doing here is I'm just dividing all of these. Divided by 5, divided by 10, divided by 20, divided by 40. If they all come up with the same answer, true. If they don't come up with the same answer, false. Okay, so you're going to do that for the two charts, A and B. Okay? Question number 2 is not in, let's see, it's number 3, it looks like. Okay. It says a turtle is running a race super uber fast. Is the relationship between distance traveled and time proportional? If so, write an equation. Okay. So you're going to go second column divided by first column. And I bet you all of the answers are going to be the same. Okay? Whatever your constant proportionality is, you just need to put it in the box here. Okay? Remember, there's videos and explanations if you don't understand, and you can always email me with questions as well.